In this video, I'm going to quickly talk about two things. The first is interrupts, which I've started to work on. And specifically, I have implemented my first BIOS interrupt. It's quite simple, but I'll show you what that looks like. I, in previous videos, talked about hardware interrupts, and then there's also operating system interrupts. And ultimately, I want to be able to write applications, maybe in C or C++, that can take advantage of all the features of an operating system, whether that's DOS or something that I build on my own. That's just a really, really simple operating system just to learn the concepts. And often those applications and operating systems will leverage functionality of the hardware through a BIOS, or basic input-output system. And in an x86 world, it seems like that's often done through interrupts. So I'm going to have a BIOS, I'm going to have some interrupts that expose functionality of the hardware. I'm going to have an operating system that might have software interrupts that allow me to, again, take advantage of the functionality of the operating systems in a consistent way so that my application, let's say written in C++, can raise or call those interrupts of the operating system that can leverage the operating system's wide array of whatever capabilities it has in it, to then turn around and maybe leverage the hardware directly, or to go through some type of a BIOS interrupt that tries to simplify or standardize some of that access to the hardware. In previous videos, I've talked about a couple of hardware interrupts that I already have in my system. So in my system, I have a priority interrupt controller, or sometimes a programmable interrupt controller is what it's referred to as. That interrupt controller has IRQ lines on it, and connected to IRQ line 1, I have something that will raise the signal when there's a keyboard key pressed. On IRQ 2, anytime I move the mouse, it raises the line on IRQ 2. And then within my BIOS, I essentially will recognize IRQ 1 as an interrupt, and interrupt 9. IRQ 2 will be recognized as interrupt 10, or hex A. And then I can do something in my operating system and say, okay, if this hardware interrupt occurs, here's the code that should run as a result or in response to that interrupt. But there's also interrupts that have been somewhat standardized. You know, if you look at the IBM PC type of standard, and one of those interrupts, as an example, that I'm starting to play with is interrupt hex 10, or decimal 16. And I'm going to use that hex 10 to get into this video services, and within that there's a whole list of functionality that I'm going to have to eventually figure out how to support the best I can given the hardware that I have. I know there's a lot of stuff that I won't be able to support, so we'll see how that all works out. But within that specific interrupt, there's different functionality, and what's going to happen is from the operating system, I'm going to be able to raise an interrupt or leverage an interrupt from the BIOS. And let's say, for example, there's BIOS interrupt 10, and within that there is a function that I'd like to print a character to the screen. Well, that print character to a screen, when I raise this interrupt 10 from the operating system to the BIOS, I'm going to have to set my A register high byte to a 0A. And that basically will tell the BIOS, okay, I want to do a write character, and that is part of this interrupt 10. And there's a whole series of other values I can put in the high byte of my A register to do different things within that single interrupt 10. And I'll pull up a web page here in a little bit to maybe scroll through some of those choices or things that I'm going to have to eventually implement and support. So we'll see how that all goes. But then there's also interrupts that are up at the operating system, and maybe these are more of a software type interrupt. You know, the BIOS interrupts are typically probably to get me to access hardware down below. So get me connected to my video, get me connected to sound, mouse, keyboard, something. Let me somehow interface with or do input-output. On the operating system, there's interrupt 21, and it has a long list of things that I'm going to have to figure out how to support in time. Maybe one example is if I set the high byte of the A register to hex 40, and then I call this interrupt 21, that's basically a request to write to a file or a device. So I might eventually write an application, let's say in C++, and in that I might have just a C++ line that says I'd like to send a character out or C out, and I want to write out this hello world string. Maybe inside of that application, then after I compile it, in the background, maybe it's calling some of these DOS functions like this interrupt 21, leveraging function 40 here, or AH equals 40. And then maybe that ultimately is taking advantage of the BIOS interrupt 10 to actually write a character at a specific cursor position. And then at the hardware level, my video card, the appropriate memory would have to be accessed and the value of the colors for the pixels would have to be set to actually represent some character on my screen. So if I was to go buy a new computer today, I'd have the hardware, I'd have my motherboard, I'd have my processor, my RAM, things like that, video card, sound card, or those things would just be built into the system board. It would have a BIOS that comes with all of this functionality put onto it. And then I'd have the operating system, maybe that would be Windows 10, Windows 11, and it would be taking advantage of maybe those BIOS features that are offered. And then I might have applications that leverage the interrupts exposed by the operating system. Now, today on a modern system, I don't know if all of this really flows exactly like that. That it might be a bit different as things got newer, but at least in the DOS days, I think this is the general layout. So I've got the hardware, I have BIOS. There's a kind of a standard set of BIOS interrupts that I'm going to have to ultimately support. And then at the operating system level, if I can run MS-DOS at some point, it will provide all of that functionality. If I can't get to that point, I'll have to kind of implement my own operating system type of functionality. And if I want to run maybe standard C or C++ applications on my system through the operating system, I'm going to have to support the standard DOS type of interrupts like DOS21 interrupt, which is this function dispatcher. And there's a long list of stuff within that. So this is all the stuff I'm trying to kind of just learn about and make sure I'm understanding it correctly and getting it straight. And I'm sure as I'm explaining this, I'm not getting everything quite right, but this is how I'm understanding it so far. If I continue into this, I would maybe say that things I've been doing up to this point in my x86 coding and putting on my flash ROMs on my system board are probably a combination of BIOS and some operating system type of stuff. So in a previous video, I started to show where I could capture input and start to run commands that would then go do things like download a file from a PC down to my 286 system. That might be more of an operating system functionality. But once I turn around and actually want to write something to the screen, maybe that's more of a BIOS type of functionality. So these two concepts maybe blur a bit in my current system, and I'm probably going to have to work pretty diligently to try to keep those concepts separate as I move forward. Because maybe at some point, the only thing on those flash ROM chips on my system board should be BIOS. And the operating system hopefully will be on a separate storage device at some point, whether that's a drive, a floppy drive, a hard drive, some type of other, disk on a chip or something like that. And then, of course, the application will also be on separate storage. Again, it might be the same storage as the operating system, but then I can run applications that are loaded by the operating system, leveraging the BIOS functionality on the BIOS chips to get access to the hardware. Now, maybe if I talk through this video services, this is the first interrupt that I'm starting to implement, and I have one of its subsets up and running at this point, and it's very basic, but I thought I would just show you the framework I'm doing this with. So first of all, I do have these declarations up top on the screen here, and in a previous video I've shown the keyboard and the mouse. So I had one video at one point where I talked about my keyboard and how that got hooked up, and the mouse and the coding that went with that. So here I have the keyboard on interrupt 9, the mouse is on 10, and then I have now made a procedure just called setup interrupts. And I see this done in other ways, probably better ways than what I'm doing, but this, during the startup of my system, I call this setup interrupts, and that basically puts into the interrupt vector table at a specific offset a pointer so that if a key is pressed on my keyboard, if that interrupt is raised, which would have been IRQ1, raising that interrupt 9, then it's going to go out and run whatever's in this KBD_ISR or keyboard interrupt service routine. Likewise, if this interrupt 10 happens, then I'm going to go run mouse ISR. And now I've added another one, which is this int 10. And for that, I have a little section down here, and I'm basically saying if interrupt 10 is ever raised, this is the interrupt service routine that I want to go run, which is interrupt service routine _video. And then I actually have the interrupt service routine in this example, and it's really short at this point. But basically, if interrupt 10 is raised, then I am going to have to figure out, well, what specific function within that interrupt am I going to try to work with? And one of them is this 0A. And 0A is to write a character to the screen at the current cursor position without specifying other attributes of the character, such as color. And so I'm going to have to set in my A upper byte, my AH, I'm going to have to, when I call this, tell it that I want to call function 0A. And I can also pass in on the lower byte of A the ASCII character that I want to print. If I put something into BH before I make the interrupt call, I can specify the page number. And if I understand this correctly, depending on what video mode I'm in, there's either a couple of pages or up to 8 pages. And I believe those pages are kind of synonymous with my video card having 2 pages. And I'm not even going to, I'm just going to ignore this if anything is in BH, and I'm always going to write these characters to both of my video pages. And then if there's something in CX, well, I can specify in CX the number of times to print the specific character. And for now, I'm just going to ignore that. And that's an easy add later, but I'm not going to do anything with that specifically. So if I want to print a character through an interrupt, what I can do in my operating system, for example, is to raise interrupt 10, but first fill in the A register, and the upper part of the A register will contain a 0A, and the lower part of the register will contain the ASCII code for the character I'd like to print. And then when I do raise it, it's going to come into here, and I'm going to check, well, which specific function am I going to process this code for, and in this case I'm only looking for 0A. There's a whole list of these that I have to get implemented. This is one function out of this interrupt. But if it is that, well, if it's not that, jump out, get out of here. But if it is that, then I just call in another procedure that I've previously shown and I already have working, which is just to print character to my VGA. I suppose I could go into that procedure and actually bring all the code into here, but for now I'm just doing a call to that existing procedure. Now the way it's going to work to actually call this then, here I have a key pressed routine. So if I press a key, I would say then I'll call it my operating system, which is on these flash chips, will recognize, or what's actually happening is it's constantly running a loop to say, is there anything new in the keyboard buffer? And if there is, do something about it. And that gets me into this key pressed. But in the key pressed, I used to say call print char directly. So you can see I've commented that out. And now I'm instead just going to raise that interrupt 10. So I'm just going to say int 10. But before I do that, remember I have to give it an AL, which is my character. So this is this line up here where I pull the character out of the keyboard buffer, put it into AL. And then in the AH, I put the 0A to specify that's the function, this print character at a cursor location, that I want to run. So I'm getting rid of the direct call to this. Instead, I'm going to go through an interrupt call, passing it what character, and I want to use 0A. So I back up a slide here. It comes into this code. I check that it's 0A. It is, so I keep on going, and then I call my print char VGA. And that expects that the character is an AL in my lower byte of my A register, which it already came in as that, so that works perfectly. And then I can finish that out. So that is the first function within an interrupt that I have implemented beyond my keyboard, my mouse. For those of you that have done this, you're probably laughing because that's not much. That's really simple, but I just want to make sure I can get the basics working here. And then it's just an effort of time, energy to go in and implement a much longer list of these. So beyond the 0A function, what are all the other functions that I need to implement? And on my system, again, this BIOS and operating system are kind of blurred for now. And in time, I'll try to be more clear about what is more of a BIOS. Like this interrupt 10 is more of a BIOS type of call. I'll probably have to implement interrupt 21, and there's a whole list of functions within that I'll have to implement. And that's more of an operating system type of interrupt. My goal is to work through that. And so maybe some of the stuff I'm doing so far kind of spans across this. Maybe some of this is more hardware stuff. Some of it's BIOS. Some of it's getting into operating system type of functionality. And maybe real quick on the topic of interrupts, I do have, and I'm going to jump into this C and C++ posting here in a second, but in this posting on my blog, I have put in some pretty helpful links to some other resources that I found. So if you're interested, you can go take a look at that. And I've got some additional resources at the bottom of this page. So I've got some good resources here that I'm leveraging. So this stanislavs.org has all kinds of good information in it. For example, I can look up interrupt 10, and here's all these different functions. And the one I've mentioned so far that I'm working on is this int 10 with setting it to A, 0A for my high byte of my A register. That'll get me into this right character at current position, and then it just shows me in the AL I need to put the character, and then how many times do I want to repeat it, things like that. And if I back up, there's a version where I can also give it color, and the color is then going to be my font color, basically my text color. But there's others on here that I'm going to want to implement pretty quickly here, like set cursor position. I have no idea how I'm going to do scrolling yet, so that might be a fun activity at some point to figure out how I'm going to scroll up or down my page. But you can kind of see through this list some of the things that I might want to consider supporting. And that's just interrupt 10. Now, if I back up, there's all these other interrupts, and another one I mentioned was interrupt 21. And so that's this DOS function dispatcher, and you can see there's a long list of functions within that. So terminate a program, display output, printer output, etc., etc. You can see open and close things, get dates, set dates, times, things like that you would expect as part of DOS, for example. And I suppose at some point I need to implement many or ideally all of these, but I don't think I'll be able to implement all, but implement at least one by one, the ones that probably are most relevant to stuff I'm trying to work with. Maybe if I go back to here, and maybe here's another link. This one is for someone else that's written some emulator, but it's kind of a nice layout. It's easy to read. Again, I can go look at interrupt 10, and within interrupt 10, if I want to go down to A, then I can read, okay, write a character at the position, character page number of times to repeat, etc. Or if I go over to 21, I can read up on that. And so in this emulator, the author's gone through and implemented what they're calling a short list. And that's probably what I'll have in my system, is a short list of the different interrupts that I'm going to support. But again, I'll kind of see how that goes and how I learn that as I move forward. And then down at the bottom of this page that I posted, I have some other things on here as far as interrupts and things like that. And there's some nice resources there. And I'll keep adding to that. And if any of you have resources that you think would be helpful that I could add to this, I'll definitely do that. So interrupts, I have lots to do, plenty to learn. And I think there's a lot of effort there. So for me to do something that sounds as simple as run DOS on my system, that is lots of assembly coding that I have to do to support all of the interrupts that DOS is going to expect to be there. Another question that's come up, I've had a few times on different videos is, could I just, or should I, why am I not using C or C++ for coding or some of this implementation? And so I'm trying to dig into that and figure out, can I do that? And And what I would say is that, it sounds like, yes, I can, but it also sounds like there is maybe some effort to just get that to work right. Maybe get it initially set up so that I can go in, compile, let's say C++ or C code into a 16-bit, let's say COM program, a command program, not an executable, something that fits within a 64K segment in DOS. That might be the simplest place for me to start. I had posted in Reddit and had all kinds of great feedback. And one of the suggestions when I asked, well, what are people using to actually build, 16-bit COM files or programs that I could possibly use instead of having to do assembly, there was a recommendation for OpenWatcom. And I think the main OpenWatcom is version like 1.9. This is what I'm going to use is OpenWatcom version 2. So I went out here and I grabbed that. I then went into my Visual Studio, and this is Visual Studio 2022, and I configured it so that I can use it as basically a fancy text editor. I can edit my C++ files here, which is what I'm going to do, and then I have a simple script that I can run right from Visual Studio that will then build me my 16-bit COM program. And then I have DOSBox running so that I can turn around and actually test out that program that I just wrote. Now that doesn't mean I can do anything with it yet on my system. So if I want to now take that COM file I wrote, what would be great is that I could then just simply load it up inside of my 286 and it could run it. But to do that, I'm going to have to support all the interrupts that assembled or compiled COM file is going to expect to be there. And then within that functionality, I'm probably going to have to take advantage of BIOS level interrupts. So there's going to be DOS type interrupts, more operating system. There's going to be probably hardware interrupts I'm going to have to get supported to ultimately make this work. So maybe I'll just walk through, I'll flip over to my actual system and show you what I have so far. Okay, so here's my development system that I've been working on. And at this point, if I look in my Solution Explorer, real quick, I've got my normal assembly file. So this is the one that I just got done adding that additional interrupt support for video interrupt 10. But I have this set up so that I can open up a terminal and it opens up a PowerShell down here. And I've got this set up so that I can tell it I want to build that, that assembly there. And that then goes out and assembles this x86 and it splits out those files for my separate ROM, my flash memory chips. And then it also does some other things like creates a modified list file that sets all of the line numbers based on the fact that my ROM starts at C0000. So as I look at that file, everything kind of matches up to actual addresses. Those are just some little helper utilities I wrote that split it and do this modification of the list file. So that's easy for me to come in, make some changes to my core assembly for the system. And so let's just consider this is my ROM and kind of operating system type of stuff. That lets me build that. But if I want to start playing with all of this C++, I can now open up a very exciting, here's a hello world. And if I want to come down here and build it, instead of using this build ASM command, I have a build CPP command. And when I run that, I can, hopefully this is readable. I don't think I can zoom into this very easily, but in this case, I said I want to basically use this Watcom, OpenWatcom is what I'm building with. And this is the command I'm using. It's a WCL. And I'm telling it to go grab that hello CPP and build that. And the output is a COM file. So I will now have a hello.com. And then I copy it to a folder that DOSBox can then use. So if I open up DOSBox, now I can go to my C drive and do a directory, and that file is there. And then I can type hello.com and actually run it. So that code that I had over here is now running. And this is 16-bit, should be a true 16-bit COM file that would work on any actual DOS system. So that is the environment that I'm going to be bouncing between, is doing stuff in the assembly code here. That's maybe more of this BIOS level and operating system level. but then I'll get into this C++ and see what can I start doing here that I can then run on my system at some point somehow. And that's what I've got to figure out how to work through that. If I go back to this posting here, I did then disassemble it. So I compiled it, I created the com file, then I disassembled it, and I posted that disassembly up here on my blog. But then this is what it comes out as. So, I wrote this simple little, what do I have there? 5 lines of code. This IO stream has a lot of functionality in it, and you can see here that this is what the assembly, at least when this was disassembled, what it starts to look like. So there's a lot there, but what I did in that, I then looked at, well, what interrupts is it leveraging? And it's interrupt 21 primarily that it's using, which is, again, that DOS dispatcher. So, and then here are the functions within that. So keyboard input and echo and terminate a process and get the DOS version number and open a file and write to a file. And I'm assuming that open and write to file is probably writing to a device since it's not a file, and it's probably more of my video device. I could be completely wrong there, but that's my guess. But then within DOS, when it would receive one of these, for example, let's say write a file or device, it's then probably turning around and leveraging a BIOS interrupt to actually write that character to the VGA. So that's the next step of how I'm going to have to figure out how this all kind of daisy chains or flows through that. But my environment is here. I think I have enough that I can start experimenting. I can test that my C++, as simple as it is, actually works and does something here in this DOS box. And then what I'd love to be able to do at some point is to then load up this file, which is like a 9K file, load that up into my 286 system. Maybe for now I could load it off an SD card, or I could just put this image right inside of my flash ROMs. But it'd be nice to be able to load that up and run it. But just looking at this disassembly, I can see there's a lot of work before I'm going to be able to do something that sounds so simple but is not so simple. And again, some of you have probably done a lot of this, and I maybe am overthinking or underthinking this. So definitely any input guidance is appreciated. I've got a couple of books on order that are going to help me maybe on the DOS programming, and one book just on interrupts. So that should be an interesting book to go through and see what I can learn as I go through that. So this is at about a 30-minute video, so I'm going to stop it here, but just kind of sharing maybe my thoughts on hardware interrupts, software interrupts, and whether it's BIOS level or operating system level, and getting into the idea of maybe I could start using C or C++ to implement, whether it's, could I use it to implement some of my BIOS, the operating system, or applications that run within that environment. I'm guessing that the technical answer is yes to all of that, but we'll just kind of have to see what I end up with here. Thanks for watching, and I think the next video I'm going to have coming up here pretty soon is getting the rest of my flash, my onboard online flashing or updating of my BIOS from the PC. That should be my next video. I'm hoping to have all that functionality working here in the coming week. And that way then, as I start cranking through a lot of code changes, it'll be easy for me to constantly update that 286 system. And I have a lot of code cleanup to do. Right now I just got pretty much one big messy file here that has all kinds of stuff in it. I need to start splitting this out and doing a lot more with include files. So that's the other type of just housekeeping work that I have to do moving forward.